Very interestingly, it works and it exhibits the behavior of a real electronic diode in every sense. So I would request my technical team to show the first slide, the slide mark A. Okay, I hope all of you can see the slide that I am showing. Here is the equivalent of a diode. You see in A, you see the diode. In B, you see the cross section of a pipe. Very simple one. Now the pipe has inside it a small wedge and, sorry, a hinge and a small circular lid. I suppose you can see that. I have marked it in a different color in part B. So please note, if you send water from the left side, then the water will flow and push the lid open because it is hinged only in the top. So it will push it open and water will flow to the other side. Now imagine if you send water from the right side, then what will happen? It will come and hit the lid and the lid will close and no water will come to the other side. This is a very simple mechanical system equivalent of a diode. Now perhaps this you appreciate and you understand, but what I want to tell you is that you can go further and show that this is not only similar, but it shows some very fine phenomena that the diode also shows. Can we see the next slide, please? The graph B. Next slide, please. Yeah. Now look at this graph. You are all familiar with this graph. We call it the VI characteristics of the diode. But if you watch closely, I have not written VI. I have written pressure flow graph. Pressure water flow characteristics. On the x-axis is pressure and on the y-axis is flow. Now imagine that earlier water valve. Can we go back to the previous slide? Okay. From the left side is positive direction, from the right side is negative direction. So from the left side you send water, the lid will open and the water will flow. Now that was a statement I made. Now I correct myself. See, imagine you put a drop of water from the left. You take a filler and just drop one drop of or two drops of water or even a spoonful of water. Do you think it will go to the other side? No, it won't. Because for one thing, that lid is normally closed. And then there is a ring inside the tube onto which the lid is hinged. So that has got a small height, as you can notice in the picture. So if you put a drop of water, that water cannot flow to the other side because it has to overcome that obstacle, small obstacle. Also, the lid, when it is closed, if you put one drop of water, the lid will not open. So there is a minimum level of water pressure that is required for the water flow to start. This is very obvious common sense. Now this is called the cut-in pressure. The cut-in pressure. When water will start flowing, that is called cut-in pressure. In the diode, electronic diode, this is called the cut-in voltage. There is no difference. So you earlier said in one direction current flows, in the other direction current doesn't flow. Now you correct yourself. In one direction current flows if there is a minimum pressure. After that current will start flowing. So now look at the graph. Let's look at the graph. Okay. You see the positive direction. You see a small red mark. That red mark shows the cut-in pressure, or in the terms of the electronic diode, cut-in voltage. Only when there is pressure up to that point, up to that value, the diode will start conducting, or the valve will start let the water flow. After that, if you increase the pressure, the lid will open more and more water will flow. The more the pressure, the more the water. But of course, it cannot go on like that forever. There is a physical limit. But generally, you can say after the cut-in point, when the pressure increases, the flow increases, or the voltage increases, the current increases. This is commonsensical. What I want to tell you is that this is commonsensical. You don't need the knowledge of electrons and holes to actually say this. Now go back to the old diagram again. Okay, look at our valve. Look what will happen if you send water from the right side. If you send water from the right side, it will go and hit the lid, and the lid will close. And the more pressure you apply, the more tighter the lid will close, isn't it? Therefore, there is no effect for the pressure. If the pressure, water pressure from the right side is increasing, it seems to have no effect on the water flow because there is no water flow. But you may see, as you increase the pressure, there is some small water that will leak into the left side because the sealing is not perfect. The lid is not sealed properly. There will be small leakage. Friends, do you recognize that in the electronic diode also you call this the leakage current? In the reverse direction, it is called the leakage current. So in the water valve also, there will be leakage. In the reverse direction, you increase pressure, there will be leakage. Now what will happen if I go and bring a, have you seen fire engine hose, very big hose, very high pressure? What will happen if I go and bring that and connect it to the valve on the right side and open it? That means terrible pressure is given to the valve. What will happen? What is likely to happen is it will break the lid. It will break the lid and water will flow to the other side. That means in the reverse direction, if the pressure is enormous, even though earlier said in the reverse direction there is no current, but in the reverse direction, if the pressure is enormous, the valve will break down and water will flow. Now look at the graph. The graph only says that. Next. So look at the reverse direction. Reverse direction, as you said, as you increase pressure in the reverse direction, negative direction, there is initially no effect. But gradually, if you look closely at the graph, you will see small current starts flowing. Water current or electric current starts flowing until after a particular point, the pressure is so enormous that the valve or the diode breaks down and conducts. So in the electronic diode, this is called breakdown voltage. The current is called leakage current and the breakdown point is called breakdown voltage, what is marked with green. So look at this graph. This graph exactly represents the characteristic of an electronic diode as well as a water valve. So this is very, to me, it was a very illuminating thing to know this. Suddenly, I felt I could understand diodes insightfully. Friends, I want to share with you that when I studied, I had the fortune of reading a book in physics. It is called the Unified Concepts in Physics. It didn't talk about the diode, but it talked about 6 physical systems and explained that one phenomena you find in one system can be seen in the other system also. And it handled hydraulic system, mechanical system, electrical system, magnetic system, and I went on to extend it to social systems also. You also can think of social systems and think of the phenomena you study in electrical engineering there. For example, Ohm's law is applicable to social systems. Pressure, movement, and resistance. All of these are there in society also. So there also the Ohm's law holds good. So if you study like that, then the concept that you are studying look very insightful, look very interesting, and very simple. This is my first take. Now we go on to a slightly more complicated phenomena, that of the transistor. So friends who are listening, you can message your questions. The organizers will collect it, and I will be able to respond to some of them, maybe in the middle or towards the end. So now we go to the transistor. Next slide, please. Okay. You are all, if you are, even students in school know this symbol. This is the symbol of a transistor. I would think that this symbol itself is very confusing, because in one way it tells me, with simple electrical engineering knowledge, it simply says 3 wires are connected together. How can it become a device? They are simply connected together. If one part of it is a diode, it still doesn't make sense. This was my first doubt. Some of you can actually go and study the history of how this symbol was arrived at. And I am not surprised that they did consider other symbols also, some of which were actually better. Anyway, now we are stuck with this symbol. I would like to ask you one question. As an electrical engineer, we are told every electrical system. Please note that if some of you are interested, I can also talk to you about what is the difference between electrical and electronics. I will tell you towards the end. If someone of you remind me, I will tell you. But I will briefly tell you that at the deepest level, there is no difference. Okay. So, in electrical engineering, one basic principle that you are told is that every electrical system can be represented as a network of resistor, capacitor, and inductor. These are the very 3 basic things in an electrical circuit. So whatever circuit you are talking about, they are only a network of resistors, inductors, and capacitors. There can be nothing else. Now I applied this question to the diode and the transistor. What is a diode? What is a transistor? So if you were able to say this, one of these, then suddenly it makes things very easy. So for a diode, the answer is actually the diode is a resistor. The diode is a resistor, but a very strange resistor. If you measure the resistance from the left to right, the resistance is 0. And if you measure the resistance from right to left, the resistance is infinite. That is the difference, but it is still a resistor. We would have to say its model will have to be written in 2 parts. One when it is forward biased, one when it is reverse biased. In the forward biased model, it is a 0 ohm resistance, or you can say very small resistance. In the reverse biased condition, it is a very high resistance, infinite resistance. But the answer is simple. What is a diode? Diode is a resistor. Now the same question is asked to the transistor. It suddenly presents a difficulty because transistor has 3 legs. Whereas a diode has only 2. It looks like a resistor. When you buy also, it looks like almost like a resistor. But the diode has 3 legs. So how do you, what is it? And can you call it a resistor or inductor or capacitor, because they have only 2 ends. This you have 3 terminals. So first thing to understand is the transistor is basically a 2-legged device with the collector and the emitter. The other one is an extra fitting for a particular purpose only, which mostly you can ignore. If you understand its effect, then you can ignore. That means it is only a connection between collector and emitter, something between collector and the emitter. What is it? Actually, unlike a diode, the transistor's name itself admits what it is. The explanation for the transistor's name is transistor means transfer resistor. What does that mean? In the simplest terms, that means it is a resistor. So friends, I would like you to believe me that transistor is a resistor, basically. And that resistor that you are talking about exists between collector and emitter. The resistance that you are talking about mainly exists between collector and emitter. This is the lowest level explanation I can give about a transistor. Transistor is simply a resistor between collector and emitter. The resistance exists between collector. Well then, what is the base? And is it an ordinary resistance between collector and emitter? Well, I would say no, it is not an ordinary resistor. Like a diode, the resistance between collector and emitter are different at different times. When are they different? Well, there are very many ways in which you can look at it. There are two major ways in which the transistor is used. One, the transistor is used as a switch, and the other, the transistor is used as an amplifier. Let us look at the idea of transistor as a switch. So please note, I have advised you, ignore the base. For the moment, ignore the base. Between the collector and the emitter, the resistance is infinity if there is no current in the base. I repeat again, between collector and emitter, the resistance is infinity if there is no current in the base. If there is sufficient current in the base, then the resistance between collector and the emitter becomes zero. Or you can say, use another word, if there is no connection to the base, then collector to emitter is open circuit. If there is a current in the base, then the collector to emitter, sufficient current in the base, then collector to emitter becomes short circuit, zero resistance. So this is like the diode. But diode has no third leg, that is all. Whatever way you measure, forward is resistance is zero, reverse is infinity. Here, if you measure from collector to emitter or emitter to collector, the resistance is still infinity if there is no current in the base. You measure the resistance between collector and the emitter in whichever direction. If there is sufficient current in base, it becomes zero. I hope you understand my basic explanation. Now let us see how you can imagine this in a very simple circuit. Let us go to the next slide. Okay. So this is the switching action of the transistor. Look at the first image. IB is equal to 0. There is no current in the base. I told you there is no current in the base. Between collector and emitter, there is an open circuit, infinite resistance. And I have connected a bulb and a battery between the collector and the emitter. In the circuit, I have put a bulb and a battery. Obviously, the bulb will not blink, will not be bright, will not lit up. Why? Because collector and emitter is open circuited, and therefore the bulb will not be bright. You send 50 microampere current to the base. Now let us, for the moment, let us not worry where it goes, how it enters. No. But if you send 50 microamperes to the base, then what happens is the collector and emitter become like a short circuit. They suddenly closed. When they are closed, what happens? The bulb is bright. So this is the switching action of the transistor. You connect any circuit between collector and emitter, it will not work if there is no current in the base. The moment there is a current in the base, sufficient current in the base, then the collector and the emitter will close together like a short circuit. Then the circuit becomes full and the bulb becomes bright. So IB is 0 to IB maximum. What I mentioned, the sufficient current, the right direction, right value. If you give a current, the circuit is closed. Otherwise, the circuit is open. That is why it is called a switch. Transistor is used as a switch. As you know, very well know, its use as a switch is more today because the computers operate with a large number of logic circuits where they need only a switch, not an amplifier. You agree? Do you agree to this particular model? So this is only one action of the transistor, which is perhaps easy to explain. The next action is slightly different. Before I explain that action, I would like to ask you, the word amplifier, I already told you I'm a bad student, so I was confused with this word amplifier. He said you send, the initial classes said you send a signal, it is strengthened. How can you strengthen a signal? So my question was, or my doubt was, is it not against the law of conservation of energy that a signal can be strengthened? Please understand, actually there is no amplification being done. The collector emitter circuit has an energy source. In our switch, you see a battery there. That is the energy source for the collector emitter. The base circuit also has an energy source. So your output comes in the collector emitter circuit that is driven by the battery there, and it is not an amplification. Actually, as we will soon see, the collector to emitter circuit produces a signal using its own power source, which has the same shape as the base signal. Because the signal shapes are same, you cannot say there is an amplification. So you must, my idea is that you must take this word amplification with a pinch of salt. You are not creating new power and energy. You are only actually, by a clever mechanism, ensuring that a small change made in the base circuit is in effect the same shape is obtained in the collector emitter circuit. But the energy is not amplified, because then the law of conservation of energy will not be holding. So I just wanted to point out this. Let us now go to the so-called amplifier operation of a transistor and see how we can intuitively understand it without talking about electrons and volts. For this, I welcome you to look at a electromechanical model for the transistor. It's an electromechanical model. It's an imaginary model. Don't think that it may work in real life. In fact, I would say it wouldn't work, because the magnetic effect that we are explaining will not be, in real life, it will not be the same. But anyway, for the moment, you take it as a teaching model. So we'll go to the next slide. Here you see the transistor, the model of the transistor. In the beginning, it may look a bit complicated and funny, but very easy for you to understand. The base current IB, which flows into the transistor, you can imagine goes into a winding around a piece of iron. What would happen if you wind a coil around a piece of iron and send a current? It will become a magnet. Very easy. It is called an electromagnet. So if you send a current IB into the transistor, it simply flows through the coil and then comes back through the emitter back to the base. So the piece of iron there will become an electromagnet. In this case, I have shown it as polarity north and south. Now, between the collector and the emitter, please trace carefully. You start from the collector, then you see the yellow colored resistor. I have noted 3 points there, 3, 2, 1. Yellow colored resistor, and then there is a break in the resistance at the end. Okay, and then you see a red pointer. The red pointer is tied to a spring onto a fixed wall. That means it is pulled to the extreme position always. And on the pointer, there is an ordinary magnet with polarity north and south, as indicated. Now, if you send a current, base current through the base, the electromagnet will attract the pointer magnet. The pointer is able to move back and forth because it is connected with a spring. So if the pull of the electromagnet is large enough, it will move. So please note, imagine what I am saying. I send a small base current. When I send a small base current, the pointer, red pointer, will start getting attracted to the electromagnet. It will start moving towards the yellow resistor. So if there is sufficient current, the pointer will first come and hit the point 1. You see the point 1 on the resistor, yellow point 1. So the moment it hits the point 1, there is a finite resistance between collector and emitter. Earlier there was infinite resistance, there was open circuit. But the moment it hits point 1, it becomes a finite resistance. If you send more current to the base, then the pointer will move closer to the electromagnet. When it reaches the point 2, the finite resistance which was there is now made into half. Half of the resistance is cut off from the circuit. And if you send maximum current through the base, the pointer magnet will come and touch the electromagnet, and thereby the pointer will stay at point 3. When the pointer stays at point 3, the whole resistance is cut off the circuit. The collector is directly connected to the emitter. There is no resistance in between. So I repeat, if you send a base current, depending on the strength of the base current, the pointer will be attracted to the resistor, attracted to slide below the resistor. And it will start from point 1. If more current, base current is there, it will go to point 2. Even more current is there, it will go to point 3. At point 3, it means collector and emitter are in direct contact. There is a short circuit. There is no resistance in the circuit. If there is no current in the base, then the pointer is pulled back by the spring and it goes to the extreme right position and thereby create an open circuit between collector and emitter, infinite resistance. No current will flow in the collector emitter circuit. I hope you understand this. And now, suppose you want to amplify a signal. Now let us for a moment, before I do that, let us for a moment ask. Suppose I send a current, the current IB, as you see in the picture, is flowing into the transistor. Suppose I reverse the direction between the base and the emitter. I connect a battery and a variable resistor and reverse the direction of the battery so that the current IB reverses. When the current IB reverses, the polarity of the electromagnet reverses. Instead of north-south, it will become south-north. And therefore, the north of the electromagnet and north of the permanent magnet of the pointer will come face to face. What will happen if north and north come face to face? They will repel each other. If they repel each other, of course, the pointer has to push away from the resistor. But that creates no effect because already there is an open circuit. If you push the pointer again to the right, there is no special effect. That means if the current, base current is negative, flowing in the direction opposite to what is shown now, then the resistance between collector and the emitter will remain infinite. There is no effect of the base current. I hope you understand. Now, suppose I want to give a varying signal in base. Let us assume a half cycle, positive cycle signal is sent to base. Can you imagine? As the current increases, the pointer will get attracted. As the current reduces, because the signal you are talking about is half cycle only, positive cycle. So as the current, signal increases, the electromagnet becomes strengthened. So the pointer will start moving, and let us say it comes to the middle, and then the signal starts reducing. Then the pointer will start moving back. I hope you all can imagine this. You can, in your mind, you can do this experiment. You can imagine this will happen. That means in proportion to the base current or in inverse proportion to the base current, the resistance between collector and emitter will change. So that means if your signal is increasing like this, then the resistance will be like this, exactly opposite direction. So when resistance is like this, if there is a fixed battery in the collector emitter circuit, that will produce a current like this. Because when resistance is low, the current will be high. When the resistance is high, the current will be low. That means your base current signal is reflected in the collector emitter circuit. That is the idea. Because of the resistance variation, which is in inverse proportion to the base current. So for the positive cycle, it is possible for you to send a signal to the base and get a similar shaped but stronger signal. How strong? That you can decide. That you can decide by fixing the collector emitter circuit and the transistor accordingly. You can decide. But there is a problem. If you send a AC signal to the base current, during the positive cycle, the transistor will react and produce a strong signal of the same shape as the positive cycle. But in the negative cycle, there is a problem. In the negative cycle, the pointer is repelled, and therefore the transistor will not conduct and no output is received. That means if you send a AC signal into a transistor normally and you have set everything for amplification, it will only amplify the positive cycle of it. The negative cycle, you will see that there is nothing, no output in the collector emitter circuit. In a way, the transistor will work like a diode. Positive cycle, there is a strong output. Negative cycle, there is no output. The diode actually will only have equal signal on the other side. Here it will be a powerful signal. That is the only difference. Now, what is the solution to this? The solution is very famous. It is known to all transistor engineers. The solution is called the biasing. You give a small voltage to the base always. It is a DC voltage. It is fixed to the base always. And over on top of it, you give a AC signal. Now, to understand that, you please understand it in two ways. You think of the battery first, because I think in electrical, you know, if there are two sources, you can remove one, analyze the circuit, remove the other, analyze the circuit, and put them together. So that's what we are doing. So if you connect a battery to the base, between base and emitter, you connect a small battery, very small voltage. Actually, you don't connect a battery, you have a resistor divider network by which you can produce a small voltage. So that positive voltage applied to the base, DC voltage applied to the base, should be such that, please note, to keep the pointer of the sliding rheostat at 0.2 at the middle of the resistor. I repeat again, the solution to make the transistor respond to an AC signal is to keep it biased, not on one side, but keep it at the middle. Unbiased means that you don't go to the extremes, you are in the middle. So you apply a small positive voltage to the DC voltage to the base circuit. The pointer comes and remains in 2 at 0.2. And now you apply an AC signal. During its positive cycle, the pointer can move from 2 to 3. It can slide towards 3. And during the negative cycle, it can slide from 2 to 1. That means the transistor is now capable of showing a variation for both positive and negative inputs. That is what biasing is. You keep the transistors big resistance between collector and emitter at the middle, because the resistance between collector and emitter is basically determined by the current to the base. So by keeping a DC voltage available for the base always, which is carefully calculated to keep the pointer to point number 2, then you achieve something. The resistance of the collector emitter circuit is at a finite value always, and with the positive signal it will move closer towards 0.3. With the negative signal it can move to 0.1. It is like saying you have a person who will listen and obey to you. So he is standing close to a wall. You ask him to come towards you, he will obey. But if you ask him to go away from you, he cannot, because the wall is there. He is standing close to the wall. So what are you doing? You are asking him to move and come to the middle of the room. When he is standing in the middle of the room, you are at the door. You can ask him to come forward, he will come towards you, to the door. When you ask him to go back, he can go. He is standing in the middle and you are asking him to go back, he can go to the wall, to the end of the wall. So biasing means keeping the dynamic operating point of the transistor in the middle of its region, possible region. That is very evident from this model that I have explained to you. Now, you may have noticed I did not talk about electrons, I did not talk about holes, nothing. My young friends who are listening to me, please believe me. If you are given an electronic circuit with this model, I already told you, don't think that this is a real model, because magnetic force is not linear. So it does not work like what I simple explanation that I gave. But this is a thinking model. So don't worry about its accuracy. I'm sure you can imagine it is linear and then understand the process. So if a circuit is given, you can explain the working of the circuit by simple common sense. That is why this model is being explained to you. Friends, many of the things that many of the operation of the electronic circuits and electronic devices, we may see that they have reflection in other systems of engineering. I already mentioned about hydraulic system in diode. See, there is a principle in thyristors. Many of you might know about thyristors. They are high power diodes which have controllable conductivity. You have a leg called the gate. So you send a current, you firing through that gate. Then only the diode conducts. That is what a thyristor is. And in a thyristor, you are told there is something called a latching current and holding current. Friends, please watch this. If you have a water tap in your house, when you are in the shower, you can actually try this out. The water tap has a latching and holding current. The meaning of the word current is water there. Especially when it is quite used, this behavior is very, very evident. That means if you open the tap a little bit, no water comes. If you observe this carefully, you will understand. A little bit of the water tap is open, no water is coming. So you carefully start increasing. At a particular point, you find that the water starts flowing from that water tap. Now increase it again. Carefully watching the position. The water increases. Now after that, you start reducing. And you reach the point where the water started flowing. It doesn't stop. That is the interesting thing. It doesn't stop. So you go a little bit behind that, only the water flow will stop. This is the holding and latching current of the water tap. So my explanation is only to, my pointing out this is only to remind you that every phenomena that you see in electrical and electronics engineering is actually reflected in very many day-to-day other systems. And when you try to connect them and explain based on them, it might give you great insights, very great confidence about talking about electronic and diode circuits. That's what I expected to tell you. I have spoken for 45 minutes now. So we have 15 minutes question answer session. The organizers may please, if students have texted questions, the organizers may please read out that, I will answer.
Thank you, sir, for a wonderful session. Sir, we have one of the participant who wants to know on the transistor as an amplifier, but he couldn't understand from the point where the IB gets reversed. So if you can just briefly explain him, he has asked a query on that.
Okay, look at this picture. If IB gets reversed, there are two things here: an electromagnet and a permanent magnet. If IB is flowing into the transistor, you see that the electromagnet attracts the permanent magnet. Permanent magnet has this point. So the permanent magnet moves. If IB is in the reverse direction, then the electromagnet's polarity is reversed. Instead of north, the left and south in the right, it will become south in the left and north in the right. So the north faces of the electromagnet and the permanent magnet come face to face. So they will repel. So when they repel, there is no possibility of closing the open circuit between collector and emitter. Do you understand? Please repeat if there is any specific explanation that I missed. Ruby, we go on to the next question and wait for this person to come back. Yeah.
Yes, sir. We have a question. One of our participant asked, "What is the difference between electrical and electronics?" Which you had mentioned earlier that you'll touch on if it is being asked.
Very interesting. Okay. Okay. I already told you, philosophically, there is no difference, but practically, there is a difference. A few things I will mention. One, um, electrical engineering deals with huge voltages and currents, but small frequencies. For electrical engineer, the frequency is typically, they talk about the frequency of 50 hertz, but they sometimes have to uh, come face to face with the higher frequencies, typically multiples of 50. For example, in an alternator that you make, you have what is known as harmonics. They are not extremely high frequencies. They are uh, multiples of 50, very often not too big, like gigahertz frequencies don't come. So high voltage, high current, no frequency. Whereas electronics engineers deal with the voltage, and they sometimes call 12 volt as high voltage. Electrical engineers don't. So they deal with the small voltages, small currents, but extremely high frequencies. So practically there is a difference. One practical difference, very interesting difference, is that Ohm's law does not hold sometimes in electronics engineering. For example, you apply such and such voltage to a conductor. The conductor conducts according to I is equal to V by R. But at very high frequencies, the conductor may not conduct but may radiate. It becomes an antenna. An effect that happens in electronic circuits because very high frequencies are being used. So that means the plain innocent Ohm's law is not as innocent as it looks. Actually, somebody, when you say Ohm's law, you must state that only when the electrical length and the mechanical length of the conductor are comparable is Ohm's law applicable. Electronics engineering, they may not be comparable, and therefore it may radiate and it may become an antenna. This is another difference. But the principles of, for example, resistance, reactance, and resistance, inductance, and capacitance are there in both. In certain resistances and inductances and capacitance which are ignored in electrical engineering, becomes very important phenomena in electronics engineering because of the because of the frequency, high frequency. So the high frequency sets a new consideration to many things. That is all.
Sir.
Yeah.
We have another participant who wants to know more on the six physical system and your application into the social life.
Yeah. See, you must take that as a bit fun. For example, you enter a bus. Right now, we don't have public buses plying. But when you have, I'm sure you can remember, when you were naughty and when you were in school and all, you might sometimes get into the school bus and give a big push from the back. What would happen? People would go forward. And how fast they would go forward? That depends on how much space is there in the corridor of the bus, how forcefully you push, isn't it? So, and how they stand back, what force they stand back. There actually you can write a Ohm's law. That is a social Ohm's law. Then we also say about reaction. Political parties talk about reaction, reactance. Reactance is a social phenomenon also. So you can actually I leave it to you to very creatively try to interpret all the phenomena that you have studied in uh, real life. Let me tell you a very uh, simple knowledge from electrical engineering and how, as it is applicable in real life. For example, you have a battery of 1.5 volt and you connect a resistance of 1.5 ohms to it. Then it should deliver a current of 1 ampere. But it doesn't deliver. No circuit would deliver. The reason is that the moment the current starts flowing, the potential of the battery drops. 1.5 volt becomes, let us say, 1.4 or 1.35. And we are told this is due to internal resistance to the battery. The battery has a resistance inside. Actually, it is a model. It's a model to explain. But look at this statement that you are making. You have a potential. Think you are the battery. You have a potential. When you start delivering, your full potential cannot be used to deliver because you have internal resistance. Very many ways in which you can actually explain this physically, I mean socially. If it is an individual, then that means your own prejudices pulling you back, that your potential cannot be delivered. But I am more fascinated to think of universities. Our universities can do many things, but they are unable to deliver what their potential is. Why? Internal resistance. I think you understand what I am talking about. Okay.
Beautifully explains. And sir, I'd like you, one of our trainer has asked on what suggestion you can give them or share your methods wherein you make things simple so that the students can understand better.
How do I do this? Is it the question?
Yeah, yeah. What
Uh,
methods you use?
okay. Basically, I would suggest you to continuously look for analogies of knowledge. Whenever you are told something, you must make an analogy. And you look for the analogy around yourself. In other disciplines, amongst uh, other similar happenings, and try to bring in life into what you are talking about. I could explain what you mean by bringing in life. In digital signal processing, there is a concept called causal system and non-causal system. In fact, most students pronounce it wrongly as casual system because we are very used to casual living. Causal and non-causal system. And if you open the book and see the definition, it's highly mathematical and not at all connected to life. You say that the output of the system yn is equal to xn minus 1, say a linear combination of xn minus 1, etc. It is such and such. If it is xn plus 1, xn plus 2, etc., it is such and such. But the teacher who taught me said the causal system is like this. A person is walking on a bridge, another person is walking towards him. He gives you a big hit. He comes and hits you. And you hit back. It is causal. Because there has been a reason for producing the output. Now, a non-causal system is when a person walks, another person walks across, you guess that he is going to hit you, and so you hit first. This is non-causal. The reason has not occurred. The reason for your output has not occurred. You predict it and act on it. It is called a non-causal. See, no student will forget this exam because there is a slight element of fun in it, but more importantly, there is an element of life in it. We are talking human beings as example. So I mentioned about this during the other lectures also about how to use multiple intelligence. So I would like to tell you in studying things, first of all, if you are a person who thinks, oh, I understood, I did this problem, so I have understood. No, the person who really understands is the person who does not understand. If you are a person who is always doubting and not unsure, please take that as a sign of your capability to become a good thinker. You are doubting yourself and you are unsure. Then it is likely that you will get an insight. If you settle for answers which the teachers give or your friends give and you settle down, then you may not be able to go into such illuminating thoughts. Yes, Ruby.
Thank you, sir. So we have a question from Harita. Explain the concept of MOSFET and IGBT.
Oh, I would like to tell you that that would require me to go and study this. I'm a electrical engineer who has not been teaching electrical engineering for a very long time. For the last 20 years or 17 years, I've been teaching bioinformatics. So I'm very sorry, I don't remember what a MOSFET is. I'm hearing that word after a very long time. So maybe on another occasion, I will read up and say that. Why don't I give you this as a homework for you to come back and tell me what it is in a model similar to what I've used? Because I'm absolutely sure it would be a very commonsensical concept.
Thank you, sir. I'm sure Harita will get back.
Okay.
Sir, do you have any suggestion for our students in the way they should be approaching and learning these things? For example, how they can be questioning, I mean, they can be go into the analysis mode. Is there any specific directions which you would like to give the students?
Friends, one thing, engineering students, science students, one thing I would like to tell you is that we have a very bad, uh, we have very bad habits, learning habits, which are not suited for higher education. That is what I have observed. One of the very important aspects of that badness is looking for very, very examination oriented books. These books, which are not, the people who have written those books are not, they're not great thinkers. They're not excited with the knowledge. They are excited with organizing some knowledge to train you to do an exam. That is where our potential, I earlier mentioned about the battery, your potential will not be delivered. So, one quick advice I would like to give you is that once you are learning a concept, forget about exams, forget about your textbook. You look at newer ways in which it has people have explained it. Now you are very lucky, you know, on the web you can see, for example, tutorial on transistors, tutorial on MOSFETs. There will be many people who have explained it, and some of it might strike you. This is one explanation I would like to. See, I was lucky that I used to read a book called Billman and Halkias on electronics. That's one of the terrible books. If I look back at it, it's one of the terrible books. But maybe very precise, very cutting edge at that time. But I was lucky to read another book called Entertaining Electronics by Sedov, Sedov. Sedov. It's a Russian author. If you read that book, you cannot write any examination successfully. Your semester exams will not be directly influenced by it. But it gave me so much excitement into electronics. It began with a question. I don't know how many of you have seen such a question in a class or in an examination. It asked first, why electronics? Why not protonics? Why not neutronics? This was the question the book began with. Have you ever thought about this question? Why electronics? Why not protonics? Why not neutronics? As you know, the atom has got protons and neutrons also. In electrical engineering, there are books which ask this question. Why is electricity supplied at 50 Hertz? Why is electricity supplied as a sine wave, not as a triangular wave, not as a square wave, not as a trapezoidal wave? Why is electricity supplied at 230 volt? Why not at 2300 volt? Why not at 100 volt? Why not at 50 volt? Why at 50 hertz? Why at 230 volt? Friends, you may notice that in America, electricity is not supplied at 230 volt. It is 110 volt. In America, electricity is not supplied at 50 hertz, but at 60 hertz. Why? So, but our examinations do not ask such questions. They possibly only ask you what is the highest voltage of transmission in India. Why is it so? How did you determine? Are the interesting questions. These questions give insight, not marks. Let me tell you, when you have insight, marks are also affected. This is a pathway to good marks also, if you are very obsessed with marks. I am not. Ruby, does that answer the question?
Yes, yes, sir. So thanks a lot for a very wonderful session. And
Ruby?
as said by Einstein, that if you can't explain it simply, you don't understand as well enough. So the basic is to understand it, and when you are able to explain it to students, I think it's very important information for trainers and also to the students, because one, you know how to teach them. Second, the student also know how to learn and analyze it. So it was a very wonderful, and I think everybody has been listening eagerly, and we were really fortunate enough to have you in ASAP so webinars. So looking forward for more webinars with ASAP. So thank you. Thanks a lot.